Good day everybody, so welcome to Noble Team YouTube channel for today, and we are going to be looking into simple machines and its calculations. Now once you come to this the subject physics, this particular simple machine is a vital topic that you need to know as a student preparing for any science exam in physics. So you need to pay maximum attention on this particular thing, because I'm going to be explaining everything that you need to know on simple machine. So my name is Noble C of Noble Team, and this is the class content of what we do be looking into. We have what is simple machine, terminologies in simple machine, classifications of machine, key formulas to take notes in simple machines, and JAMB bullet points on simple machine, and solving of 15 solid JAMB questions on simple machine. Now in this particular 15 solid JAMB pass question, I'll give you 5 as an assignment. You solve it and drop it in the comment box, and we are going to be solving 10 solid questions now in class. So all you have to do is just to follow me closely, and I'll advise you to make use of either your earpiece, your headset, or either your earpod to avoid anything like distractions. Now let's start with what simple machine is. So just take note that I'm not going to be writing everything out. You understand? So you just pause the video, write the definitions, because writing it out will take a long time for us. Now let's look into what is simple machine. Now once you hear about machine or simple machine, what comes to your mind? Now simple machine, or machine rather, is a tool that makes work easier and faster. Yes, that make work easier and faster. For example, now if you want to sweep, you understand, the broom that you make use of, for you to be able to sweep the floor, you understand, is a machine. Because instead of you to start picking it, you will notice that the broom will help you to sweep everything at once. So that is why it is called a machine. Understood? Now let's look into the terminologies we need to take notes in simple machine. This is where you need to pay maximum attention. So see, let me tell you, even though you know it, do you understand, don't do over sabi. Do you understand? Just follow me closely, because you might have, like, you will hear what you have not heard before. You understand? So let's look into the simple machine, terminologies in simple machine. Now once we talk about simple machines in terms of terminologies, we have number one. Let me make use of this place. Number one, we have what we call the load. We have what we call the effort. We have what we call the mechanical advantage. Mechanical advantage. Then we have the velocity ratio advantage. We have the velocity ratio. We have velocity ratio VR. We have the efficiency. Now these are the key terminologies in simple machine: the load, the effort, the mechanical advantage, the velocity ratio, and the efficiency. So I'm going to be explaining everything one by one, so just follow me closely. Now what is load? Now load is the force that is being overcome. Yes, simple. Load is the force that is being overcome. Now the next one is effort. Now once we talk about effort, now this is the simple definition of effort. Effort simply means the effort, the force, not the effort, the force applied to lift the load. The force applied to lift the load. Now for example, now you want to eat, you just pick up your spoon and dip it inside your food. Do you understand? To eat, the force that you applied to do what? To lift that spoon up is what we call what? The effort. Grab it now. Now we have the next one, which is what? The mechanical advantage. This is where you need to pay maximum attention. Once you hear mechanical advantage, they are simply talking about what? Force ratio. You understand? Another name for mechanical advantage is also called force ratio. Mechanical. The short form is what? MA. Can be also called force ratio. This point must be noted. Now, what is this particular mechanical advantage all about? It is the ratio of load to effort. It is the ratio of load to effort, which is L is equals to what? E. This is what they are trying to say. Now, let's move into the velocity ratio. Now, once you hear velocity ratio, what comes to your mind? Now, velocity ratio can also be called distance ratio. Velocity ratio can also be called what? Distance ratio. So, you take note of it. Let me write it down. And also be called distance ratio or speed ratio. Anyone. So now, once you come to this particular thing, what is the definition of this velocity ratio? Now, velocity ratio is the ratio of distance moved by the effort to the distance moved by the load, which that simply trying to explain that it is this. I hope you can see it, which is VR is now equals to the distance. I will just represent it with the no need of me writing it by the effort divided by what? Distance moved by the load. And this is what I'm trying to explain. You are done. So just grab this formula and grab the formula of this, which is mechanical advantage is load over effort. Now we have the efficiency. This is where you need to pay maximum attention. Now once you hear efficiency, what comes to your mind? Now efficiency, once you hear efficiency, just know that talking about something that is what 100%. Do you understand? Now coming to this efficiency, it is, remember what I said in this particular thing. Remember force ratio, remember velocity ratio, and yes, force ratio can also become mechanical advantage. Just take note of what we said. Now let's look into this efficiency. Now once we talk about efficiency, now efficiency is the ratio of work output to what? Work input. It is the ratio of work output to work input, which is, I'm going to be having what? EF is now equal to what? Work output, which is WO. I'm going to be representing it with this particular short form, and what? WI. This is what I mean. You understand? It is the ratio of what? Work output to work input. Now this work output can also be called load, can also be called what? Load, which is L, and this one can also be called what? E, which is multiplied by what? 100%. That is why I say that efficiency of the machine is 100%. Now I'll explain why it is 100%. Do you understand? Now coming to this, I want us to take just 2 more points. Now the point I want us to take note of this is that in the efficiency of a machine, MA is equal to VR. Now what am I trying to explain? This is particular in what? Ideal machine. Ideal machine. Understood? Now in this particular efficiency, the VR, or rather the MA, is greater than the VR, and it is called what? The real machine. So this, take note of this point. Very, very important. Take notes. You understand now? So we are done explaining the terminologies in simple machine, which is the load, the effort, the mechanical advantage, the velocity ratio, and the efficiency, and we are done. You understand? I explain all these things now. Now let's look into classifications of machines. Now once you hear about classifications of machine, because we have many types of, like we can call it either class or types of machine. Now I prefer calling it classifications of machine. Now once you hear classifications of machine, they are talking about levers, pulleys, inclined plane, and so on. So we do be looking into them. Yes, we do be looking into them. Now let's look into the classes of it. Now first one we do be looking into is what? The lever, because we all are familiar with what? The lever. Now this lever works on the principle of moment. Yes, this is a very core jump point, bullet point rather. It works on the principle of moment. It works on the principles of moment. Yes. So in this particular lever now, we have what we call the pivot, or we also call it the fulcrum. Yes, the fulcrum. Either we have the pivot, we call it pivot, or the fulcrum. This is where it comes in place once it comes to lever. Yes. Now we do be looking into the 3 classes of lever, which is the first class lever, the second class lever, and the third class lever. Now once you hear first class lever, pay maximum attention, because we'll be solving questions on this, and you will be able to know how to differentiate between first class, second class, and third class, because I'm going to be releasing some important shortcuts that you need to know. Now the first one is what? The lever, which is the first class lever, which is what I'm going to be writing it here because I don't have enough space again, or I will just wipe it if there is not space again. Now I have the first class lever, which is the first. Now once you hear about first class lever, just know that the fulcrum is between the effort and the load, which is the fulcrum is between the effort and the load. The fulcrum is between the effort and the load. Now let's take an example of it. For example, let's take a seesaw. Yes, a seesaw. Once you have a seesaw, there is a pivot on it, which is something like this. I have it. I put this particular pivot at the middle of it. This is what we call what? The seesaw. This is what we call what? The seesaw. So now you pay maximum attention in this particular level. Now, sorry, let me just pick up my cover. Now I hope you understand why I say this is the pivot. You understand? And yes, this is the pivot, and this is what this is. So this is the pivot, this is the effort, and this is the load in it. So this is an example of what first class lava. Now I want us to take note that in first class lava, mechanical advantage and velocity ratio is greater than 1, and also at the same time can be less than 1 or equal to 1. Now this is what I mean. That in first class lava, that NA and VR is equal to 1. Yes, this is 1. Then I have this, which is also greater than 1, or I have this, which is also less than what? 1. I will explain these particular points now. Do you understand? Just follow me closely. Now, why I make this particular point now is this. Imagine you have a seesaw. Do you understand? Your friend is sitting here. Your friend is also sitting here. You understand? And both of you are being seated at the edge of the point, like at the end of the seesaw. You notice that the seesaw will balance. Yes, it will balance enough. No, that is why I said what the MA and the VR is what? Equal. Now, let's take the point for this, which is can be also greater than 1 sometimes. This is it. Imagine your friend is sitting here, and also your other friend is not sitting at the edge of that particular what seesaw. You will notice that you that is sitting at the edge will have what? More mechanical advantage and velocity ratio. Do you understand now? So that is why it can also be equal, greater than 1. Now, in the vice versa of this, do you understand? If your friend is sitting at the edge of this and you're also sitting at the end of this, you notice that this what you guys will what the person with the higher mechanical advantage will do what will be less than 1 or equal to 1. You understand what I say? Now let me come again in this particular less than 1, because you need to pay maximum attention here. Now imagine I have a seesaw. Yes, I have a seesaw. You are sitting here and your friend is also sitting here. You will notice that the person with the smaller mechanical advantage will not have that weight, because you are sitting near the pivot. You understand now? It's simply the vice versa of this. You understand? It's simply the vice versa of this. So this is what you need to take note. Example of first class lava is the scissors. Now take for instance, you have a scissors. You put your hand. That place that you put your hand is what we call the effort. Then the middle of that place is what we call the pivot. And the blade that used to cut something is something we call the load. I hope this is understandable. Now let's look into the second class lava. Now let's look into the second class. In second class, the load is between the effort and the fulcrum. The load is between the effort and the fulcrum. This is the shortcut to remember all these things. Don't cram it. You understand? Allow it to stick into your memory. So now, once we talk about this second class lava, we have an example of which is the wheelbarrow. Yes, wheelbarrow is an example of second class lava. So now, in this second class lava, mechanical advantage and VR are greater than 1. That one is stable. Yes, I will explain. Mechanical advantage and VR are greater than 1. Yes. Let me explain. This is what we normally do in our everyday life. Now let's take for example, you have a wheelbarrow. You brought a wheelbarrow. You put either a sand or anything like that carries the load. You notice that your efforts to lift that load. Do you understand? You have an effort to lift that load up. Do you understand? Because the fulcrum of that wheelbarrow is the tire. Then the load is at the middle of it. Then the effort is you lifting it up. Do you understand? So that is why the mechanical advantage and the velocity ratio is greater than 1. I hope you understood. Now let's look into the third class lava. Now in third class lava, the effort is between the load and the fulcrum. The effort is between the load and the fulcrum. Now example of it is the broom. Do you understand? Example of this particular thing is the broom. Now for example, let's take broom for example. Yes, because we normally do this, but before that, just take note that MA and VR is less than 1. MA and VR is what? Less than 1. Is a third class lava. I hope you all understand this. Now I want us to take another bullet point. Yes, now in this particular classes of lava, just take note that the first class lava and the second class lava are what? Force magnifiers. Do you understand? Are force magnifiers, because both of them you applied force in them. But in third class lava, they are called the distance magnifiers. Now let me write it out here. First and second, we call it what? The force, which is F. Let me write it in full. Magnifiers, MAG, magnifiers. Then the third, we call it the what? The distance, or rather the speed magnifiers. The speed magnifiers. So let me explain this distance magnifier, because for example, using that same group, you will notice that the distance for you to be sweeping is why it is called the what? The distance magnifiers. Now the next one I want us to look into is the pulley system. I want us to look into pulley system. Now, what is pulley, or rather pulley system? Now, pulley system is a type of machine that is used to raise or lower heavy load. That is used to raise or lower heavy load. Now, in this pulley system, I want us to take note that the number of pulleys determines the number of velocity ratio, which is simply means velocity ratio, which is VR, is equal to the number of pulleys. Number of pulleys. Because we are going to be tracking questions on this, so you know where to incorporate this. Now, what am I trying to explain this? In terms of, you have a diagram and you have a pulley, and you have something of 6 pulleys in that. Do you understand? In that 6 pulleys, that's pulleys, like that 6 pulleys in that particular diagram determines your what? Your velocity ratio. You understand now? Now, I want us to look into an inclined plane. We have inclined plane. Now, in this inclined plane, it is used to raise heavier load from lower to higher level. For example, this, I have something of this and I want to raise it up. For example, for those people that is importing cars, you will notice that they import, like they use inclined plane to lift that vehicle inside the container. You understand? Now that is it. Now in this inclined plane, since it is horizontal, that is where we have its velocity ratio, which is VR. VR is now equal to what? 1 over sine theta. Yes, this is how to get the velocity ratio of an inclined plane. Now the next one we want to look into is the wedge. Now once you talk about wedge, all these big vehicles normally use in their vehicle, all these luxurious motor, big motor that carry sand. Yes, so this wedge is a combination of, sorry, let me take my marker. Now this wedge is a combination of what? 2 inclined plane. Yes, it is the combination of 2 inclined plane that is held together by cohesive forces. That is held together by what? Cohesive forces. Now, once we talk about wedge, we are talking about combination of what? 2 inclined planes, which is being held by 2 cohesive forces. Now this point must be noted. Now we have formulas that we need to take note in this particular way. Yes, because in some questions, there is how technical questions can come into this, so you'll be able to solve fully on it. Now in this way, we have ways to get the what? The velocity ratio. Now the velocity ratio of this wedge, for me to get the velocity ratio, I'll simply use this. Let me use my red marker to avoid confusion. Now once you have wedge, which is VR, is now equal to what? The height of the wedge, which is W, then divided by the thickness of the wedge. This is how to get the velocity of what? Of the wedge. You understand? I hope it is entering. Now the next one we need to take note is the gears, and the the gears. But before that, let's look into the wheel and what? The axle. Now once you hear about the wheel and the axle, what comes to your mind? Just remember that in wheel and the axle, they have the same speed, the same frequency and speed. Yes, because you just make use of something of this what are they calling this machine that is used to grind tomato. You notice that once the speed is increasing, the frequency of that particular fan belt is what is increasing. You understand? So the frequency and the speed are increasing at the same time. So this is a vital point that you need to take notes. Now, in this particular gears and axle, I want us to take note of the formulas. I want us to take note of the formula because question normally comes out in this particular one, and so many people normally fail it. So that is why I want us to take note of it. Now, the formula for it is, which is the wheel and the axle. The wheel and the axle is what? R over R. Now, this particular big R is for the what? Wheel, and this is for the disc, which is for the axle. You understand? I hope you understand this. Now, the next one I want us to look into is the what? The screw jack. The screw jack. My board is already filled, but I will try and look for space. Yes, because I'm not close with my duster here. Now, I have the screw jack. Now, this is what we call the screw jack, which is the screw jack. In screw jack, we use it to lift heavy loads. For example, all these jack that we normally use to lift motor if we have a flat tire. Yes. So we have two formulas that we need to solve this screw jack. It depends on the parameters given to you in each question. Now we have 2 pi what? R over what? P. Or we have 2 pi L over what? P. Now, this P is something that we call the pitch. We call it pitch. Yes. And the R is the radius. It depends. This is the pi. Then L is the what? Is the length. Now, the last point I want us to take note is the hydraulic press. Now, once we hear hydraulic press. Now, this particular point falls under the what we call the Pascal's principle. Yes, this is what we call Pascal's principle, which is when we have F2 over F1 is equal to A2 over F2 over F1. Do you understand? This is what I mean by over A1. This is what we call the Pascal's principle. But I'm not going here. Do you understand? I just want us to just refresh our memory. Now, once we hear this hydraulic press, and this hydraulic press works on the principle of Pascal's. Do you understand? And in this Pascal's principle, we have formula that we need to get to for us to be able to solve this our hydraulic press, which is the velocity ratio. Now, coming to it, we have two formulas. Yes, these formulas are very easy for you to do what? Stick it into your memory. We have when we have this. Let me use black because this board is already filled, because I'm going to wipe it now. I have MA is now equal to what? A2 over what? A1. Now I'm going to be explaining what this A2 and A1. This A2 and A1 is not something of normal area, or it's not something like area or anything. Do you understand? Now in this A2 we call it the large piston. Yes, we call it the large piston. A2 is the large piston. Yes, while A1 is the small piston. Now coming to the other formula, we also have when MA. Yes, let me write it. Let me wipe this. When we have MA is now equal to what? R square over R1. So which is this one? Yes, 1 and square. Both of them are squared. Yes, which is the radius of the large piston and radius of the small piston. Now the next one I want us to look into is the key formulas to take notes in simple machine. So I'm going to wipe the board out. And I'm going to pause the video so I'll be able to wipe it out. All right, so we are done with this particular one, which is the definition of simple machines, terminologies in simple machine, then classifications of simple machine. Now the next one I want us to look into is the key formula that you need to take note of, because it's not when we start solving questions, you'll be asking questions, where do we get these formulas from? So I'm going to be listing the formulas out. You take note of it. Now just take note that in velocity ratio, which is VR, yes, in velocity ratio 1 over what? Sine theta. I've listed this out for an inclined plane because it is horizontal. Now we also have it that efficiency can also be this, which is MA divided by what? VR. VR, this is VR dot VR, then multiplied by what? 100, because efficiency is percent. Now, what do I need to write again? Okay, I have mechanical advantage, which is load over effort. Yes, and I also have the velocity ratio, because we have two formulas in solving it. which is the work outputs over the work inputs. Yes, and also you take note of those classifications that we did. Take note of the formulas under them because they are very, very important. You take note of the formulas under them because they are very, very what important. So I want us to take note of this. I think I explained the hydraulic press. Yes, take note of that formula because it's very, very important. You take note of that velocity ratio of screw jack. It is very, very important. And also you take note of this because we are going to be applying this sense of force and weight here when we have something of F is now equals to MA, and also weight is now equals to what? mg. So this g is coming in place due to the what? The gravity of it, because once we input weight, we are talking about what? Gravity. Do you understand? Once you input force, we are talking about acceleration. So this is just key things that you have already done since your SS1. Yes, so this is the formula that I want us to take note of. Yes, just take note of these formulas. Yes, now the next one I want us to take note of is the JAMB bullet point on simple machine. So I've already listed the JAMB bullet point on simple machine. I've already listed it out when we are just doing with the definitions and deriving the formulas of everything. So the next thing I want us to look into is solving 15 solid JAMB past questions. Remember, I said that I'm going to be giving you 5. Then you solve and give it to me inside the comment box. Then I'm going to be solving 10. Do you understand? So let's start by solving question 1. So let's solve questions. I think I made a mistake here. Yes, the velocity ratio. So in this particular velocity ratio, this is the efficiency. Yes, this is the efficiency of it. Let me just wipe it. Yes, so that is why you need to pay attention to everything we are doing. So this is efficiency. This is for efficiency, where the VR is just the ratio of work done. Yes, the distance moved by the effort. Distance moved by the effort. Moved by the effort, then divided by what? The distance moved by the load. So I want us to take notes. I think I didn't list this out. I want us to take note that the work output is always greater than the work input, which is the load is always greater than the work input, which is the effort. And I also want us to take note that mechanical advantage, yes, mechanical advantage is always less than the velocity ratio. Is always less than the velocity ratio. We do be solving questions, you understand why I said so. And also take note that mechanical advantage, yes, you need to pay attention here. This one is very, very important because it is a very like a core important JAMB first question. Just take note that mechanical advantage and velocity ratio, they don't have any units. They are unitless. And take note that anything that don't have units, they are called what? Like they are dimensionless. Yes, anything that don't have units are dimensionless. Just go back to your dimension. You understand what I'm trying to say. Now let's solve question 1. Question 1, the question will appear on your screen. So all you have to do is to do what? Pause it and listen to it. Now question 1 says this. Now question 1, it says the efficiency of the pulley system that is being showed above is 80%. Then find the effort E required to lift a load of what? 1,200 Newton. Now this is how to identify an effort and also identify a load. It's very, very simple. All you have to do is just to read that question calmly. You understand? You read it calmly. Now this is how to understand and also figure out the load and the effort. Now once you hear lift, that's simply talking about what? You inputted effort in it. Do you understand? To lift something is effort. Do you understand? So that is it. Or lift or raise. We are done. Now this is the question. We are asked to get the effort of it. We are asked to get the effort, which is the effort. Then we are going to be making use of E, which is efficiencies. Now m dot A over VR multiplied by 100%. Just listen carefully. Pay maximum attention. So our efficiency is what? 80%. So I'm going to be using two methods to solve this. You understand? Anyone that is suitable for you, you are good to go. My efficiency is what? 80. Is now equal to. Now, my mechanical advantage is what? Remember, my mechanical advantage is load over effort. Now, this is what I'm going to do. Pay maximum attention, no, which is 80. I'm going to be what? Having load over effort over what? VR. Multiply by what? 100%. Yes, I'm not doing magic. Just follow me closely. I have this, which is 80 is now equal to, my load is what? They said the load is 1200 Newton divided by what? The effort. Then remember, like this is very simple. Remember that once we have this and we want to raise this up, it's going to be what? 1 over what? The velocity ratio. Simple. You understand? Yes. So which is going to be what? Multiply by 1 over. Then how many pulley systems do we have here? We have 1, 2, 3, 4. Yes, we have 4 pulley system. 4 pulley system, which is going to be what? 1, 2, 3, 4, which is 4 times 100. 100 over 1. Yes. I hope you understand the little logic here. So now it's going to be what? 1200 multiplied by 1 and also multiply by 100. Yes, let me just do the calculations. Let me also do my calculation so we can know who is correct, because I'm not perfect. Yes, so 1200 multiply by 100, you give me one, will give me 120,000. Then divided by what? By 4. I have 30,000. So it's going to be what? 80 is now equal to 80E, because we cross multiply this, which is 80 is now equal to what? 30,000. Then you now divide with 80. So why am I dividing with 80? The coefficient of what? E divided by 80. So it's giving me what? 37 point what? It's giving me 37.5 Newton. Yes, it's not 37.5 Newton, sorry, 375 Newton. So the correct option to this question is what? Option D. You can see how I solve this. Now, so many people can choose another way to solve it, in which that is the one I prefer the most, because me solving this like this is giving me something like an extra minute. You understand? Because the one I'm going to use now is just within 30 seconds and done. Now this is how I normally solve with it. I'll just come, this is 100%, and remember that efficiency is just 100%. I'll just come here, literally write 0.8 and wait and see what I'm going to do. Since efficiency is what, I'm just going to write 80 divided by 100 is now equal to 1200 divided by what? E, multiplied by 1 over 4. Yes. So what am I going to do? This will divide. I'll have 0.8 is now equal to 1200 divided by what? 1200 divided by 4e. Yes, divided by what? 4e. Now what am I going to do? I'll cross multiply. Once I cross multiply, I'll have 1200 is now equal to 4 times 0.8 is what? 3.2. Then 3.2, 1200 divided by 3.2, 1300 divided by 3.2 will give me what? 37. Will give me 375. Sorry, almost this 37 is entering my mouth. You can see both of them are the same. So I just choose to be what? Going with this particular method, because I'll just look at the percentage. Once a year, 75 efficiency. Just know it was 0.7. Just don't stress yourself going to this. It depends on you. Now let's solve question 2, because we are already done with question 1 and the correct option is option D. Now let's look into the question 2. Remember, you will solve 5 for me, so don't joke with me. Now the question 2 says, if a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, then its velocity ratio will be what? Do you understand? So this particular one is very simple. This particular one is very simple. So since they said inclined plane, remember what I said here, that the velocity ratio of an inclined plane is what? 1 divided by what? Sine theta, and sine theta is what? 0.5. Yes, just calculate it. Sine theta is what? 0.5. Sine theta is 0.5. So which is going to be what? VR is now equal to 1 over 0.5, which is equal to 2. You are done. So we have solved question 2. So all you need to do is just to allow these formulas to stick into your memory. Now let's solve question 3. Question 3 says this: a machine requires 1000 joules of work to raise a load of 500 newton through a vertical distance of 1.5 meters. Then calculate the efficiency of the machine. Yes, calculate the efficiency of a machine. So coming to this question, we have our load to be what? 500 newton, but we need to get our what? Our effort first, because since we have 1000 joules and also we have distance, that is why I said work output divided by what? Yes, where did I say? Yes, this formula. That is when I say work output divided by the work input. Do you understand? Yes, that is why I said so concerning this formula. So we are not going to be making use of this. Do you understand? So once we make use of it, our work output is what? The load, which is what? 500 newton. But our work input, yes, our work input is the distance moved. Yes. So coming to this, our work input, I have 1000 joules and also have the distance of it. What am I going to do? I'm going to be multiplying it to get my force. Understand? I'm going to be multiplying it to get my force, which is what? 1000 multiplied by 1.5. 1000 multiplied by 1.5 multiplied by 1.5. I'm going to be getting 1500. Yes, I'm going to be getting 1500. Now 1500, which is 500 divided by 1500 multiplied by 1000, which is going to give me what? 33.3. This is what I did, which is efficiency, because we are looking for the efficiency, which is equal to 1.5 multiplied by what? By 1000 divided by, no, this top is going to be what? 500 over 1.5 multiplied by what? 1000 multiplied by 100%, because efficiency is what? Percent. Now once you do this, you have this to be 500 divided by 1500 multiplied by 100, and it's going to give me 33.3%. Now let's look into the option to know which one is correct. Option A is correct. I hope you understand. Now the reason why I'm not using this is because I don't have velocity ratio. Do you understand? In the question, we don't have velocity ratio, so no need of me using this, because me using it, I'll not get any answer. Do you understand? Yes. Now let's look into the next question, which is question 4. This question 4 is very, very simple. Yes, if you fail it, it simply means that you are not with us. Now once we hear this question 4, and I think it's very, very simple. Let me read it now. Question 4. In an ideal wheel and axle system, R stands for the radius of the wheel, which is the big R, and the small r is the radius of the axle. Now, what is the mechanical advantage of it? Remember that mechanical advantage and velocity ratio, that are the same thing once it comes to all these classes of machine, except pulley systems. Yes, except pulley system. Now, coming to this, we have option A to be the big arrow over the small r. Option B, arrow over like the big R, the small arrow divided by the big R, then squared. And other option, which one do you think it is correct? Remember I explained this. So option what? Option A is very, very correct. Now let's look into question 5. You can see how these questions are very, very simple, because I've explained everything you need to know. So don't joke with it. And also, if you are enjoying this particular video, make sure you hit the subscribe button, like and share it to your friends, because they are going to be gaining a lot. Right, now the next one is question 5. We have solved question 1 to 4. Now question 5. the velocity ratio of a machine is 5 and its efficiency is 75%. What effort would be needed to lift a load of 150 Newton with the machine? So in this question, we are simply asked to get the efficiency of it. Let me keep my phone. Or rather, yes, let me hold it because I'm going to be writing out the parameter. It's just the marker is very, very tight. Okay, it have opened. Now, we are asked to get the efficiency of this. No, not the efficiency, sorry. We are asked to get the effort of it. Now, my efficiency, I'm going to be using the short method of it. I'm not going to be using the long method again. Now, the efficiency is what? 0.75. How did I got the 0.75? Just 75 divided by 100. You understand? Which is going to be what? 0.75 is now equal to, then my load is 150 divided by what? E. Then multiply by 1/5. So now 0.75 E is now equal to 150 divided by 5 will give me what? 150 divided by 5 will give me something around 30. 150 divided by 5, I want to be sure, will give me 30, yes. Then 30, which is my effort, is now 30 divided by 0.75. Divided by 0.75 is giving me what? 40 Newton. So now, what option is correct? Option B is correct. Now, I want us to imagine something I just explained when I said that the load is always greater than the effort, which is the work output is always greater than the work input. Yes, this is it, which is 0.75. This is my load. Do you understand? This is my load. Do you understand? This is my load, which is 150 Newton. Then, but my effort is now 40 Newton. You can see that the load is always greater than the effort. Do you understand now? Now, let's solve question 6. Now, question 6 says, which of these is a second order lever? So this one, I don't need to say the answer. Do you understand? All you have to do for me, just give it to me on the comment box, inside the comment box rather. I don't need to explain this again because I have explained it when I was explaining classes of levers. Now let's look into question 7. Remember, don't forget to submit my assignments. Now question 7. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Then calculate the effort put into the machine if it has a velocity ratio of 4. Now these are JAMB questions, so you don't need to do what? To just rush this question. Once you see anything calculation, make sure you read the question carefully, because at a point, because this thing normally happens to me, I rush to solve the question, and after solving I'll be rejoicing that I've seen the answer, not knowing that I solved for another thing. That is why you need to follow the question very bit by bit. Don't just rush into the question because you knew it, you understand, or you know it rather. Now I have this. We are asked to get the effort. We are just calculating effort. Just relax. We are going to solve another question, quickly JAMB question. So now this one, my efficiency is 75, which is also 0.75, is now equal to, my load is 1000. I'm looking for E, which is multiplied by 1/1. My velocity ratio is 4, which is 0.75, is now equal to 1000 divided by 4. Then 1000 divided by 4 will give me 250. Yes. Then, which is E, is now equal to 250 divided by 0.75. 250 divided by 0.75. So it's going to give me 3.33 to infinity. Yes. Then we add our units, which is Newton. Do you understand? So our correct option to this question is option A. So we have solved up to 7 questions now, and it's remaining 3. And I'll give you 5 as an assignment. You solve and give it to me inside the comment box. Now question 8. In this question 8, pay maximum attention. It says, in a wheel and axle mechanism, the diameters of the wheel and the axle are 40 cm and 80 cm respectively. Given that the machine is 80% efficient, what effort is required to lift a load of 100 Newton? Now in this question, remember, we are going to be solving for the radius of it and also to get our velocity ratio, because that they talked about the wheel and the axle. Do you understand? It's not because that they didn't give you velocity ratio, simply means that you cannot make use of this formula here. It's a lie. That is why I say read the question bit by bit, and that is why I explain the classifications of machine, so you can be able to know the formulas under the velocity ratios. Because if you don't know the velocity ratios of the formulas in that particular classification of machine, if you encounter questions on simple machine, you cannot solve anything. Do you understand? That is why I explained everything that you need to know under classifications of machine. Now in this particular one, I need to convert those cm to meter. Do you understand? Because the standard unit of measurement is what? Is in meter. So I'm not going to be using centimeter, because centimeter is not the standard unit of what? Length. Now converting it to meter, I have my 40 cm is going to be 0.4, and my 8 cm is going to be 0.08. and this thing that you need to know all these things. It's very, very simple. Just know that if you divide 10 divided by 100, because it's divided by 100, everything is like to convert from centimeter to meter. Yes, it's divided by 100. So but to convert from meter to centimeter is multiply by 100. Now this is how a little trick to know it. Once you hear divide by 100, just know that anything that is single, yes, anything that is single, which is from 9 downwards to 1, it is going to be 0.01, 0.02. But if it has two double values, for example from 10 upward, just simply know that it's going to be what? 0.1, 0.2 if is 20. But if you have three figures, just know it is going to be what? One figures, and it's like 0 is not going to be attached to it, which is going to be 100 divided by 100 is 1, which is 1.0. Do you understand? And 200 divided by this, and so on. So that is how to know it. It's not everything that you punch on calculator. Now I have it to be 0.04 divided by what? 0.08. 0.4, not 0.04. 0.4 divided by 0.08. 0.4 divided by 0.08. So my velocity ratio here is what? 5. Yes. So in the question, we are asked to get the effort of it. So we have gotten our velocity ratio. So we just move on fast to solve for the effort of it. Now my velocity ratio is 5. Then my efficiency is 80. Yes, which is 0.8 is now equal to my load is 100 divided by what? E, multiply by 1/5. Yes, multiply by 1/5. Excuse me, I'll cross multiply. I'll have this, then 25. Yes, which is E is now equal to 25 divided by 0.8. I think this is around something of 40. Let me be sure. 25 divided by 0.8. 25 divided by 0.8, yes, is 31 point what? 25 divided by 0.8. Wait, excuse. Okay, I made a mistake here, which is 0.8. Yes, I made a mistake somewhere. This is where I made a mistake. 100 divided by 5 will give me 20, not 25. So it's going to give me 20 divided by what? 8. 0.8 is going to give me 25. So my E is 25%, and we have solved for it. Yes, and we have solved for it. Is there anywhere we are making a mistake? No. So this is the correct answer. Let's look into the question to know which one is correct. So option C is correct, 25 Newton. Sorry, because I think it's efficiency 25 Newton. So this is question 8. Now let's look into question 9. Let's look into question 9. So make sure that you master everything that we have done, because there is no way after solving up to 10 solid questions in simple machine you will not be able to solve any question. It's not if I give you 5 questions and you will not be able to get at least 4/5 in it. No lollipop for you. So number 9, what effort will a machine what effort will a machine of efficiency 90% applied to lift a load of 180 Newton if its effort arm is twice as long as its load arm. So this particular question is very, very tricky. Remember, they say twice. So I'm going to be solving it. You understand? So in this question, do we have velocity ratio? Yes, we have velocity ratio. Now this is why we have velocity ratio. Remember that velocity ratio. Remember when I was explaining velocity ratio? Velocity ratio is the distance moved by the effort through distance moved by the load. Now looking at this question, they say if its effort arm is twice as long as the load arm. You understand? It simply means that the velocity ratio between this particular load and the effort is 2, twice. If they say thrice, it simply means 3. Do you understand? So this is very, very simple. So I'm going to be using this, which is, we are asked to get the what? The effort. Then the efficiency is what? 0.9, which is 0.9 is now equal to, then my load is 180 divided by what? The effort. Yes, this is it. Divided by, because you see the question on screen, divided by the effort, then multiply by 1/2. Yes. So now I'm having what? 0.9e is now equal to 90. Then 90 divided by 0.9. Excuse me. 90 divided by 0.9. Just punch it on your calculator. I have it to be 90 divided by 0.9. 90 divided by 0.9. I have it to be what? 100. So the answer is what? 100, which is E is now equals what? 100 Newton. So you will notice that everything that I've been solving under this effort load, you notice that the load is always greater than the effort. So that is why I say that the work output is always greater than the work input. Now let's solve the last question, which is question 10. You understand? Just grab this. Once we hear twice the load and the effort, simply means that talking about the what? The velocity ratio between them. You understand? Now question 10. A machine whose efficiency is 60% has a velocity ratio of 5. If a force of 50 Newton is applied to lift a load, then yes, a load P, what is the magnitude of P? So that is why I always say follow the question bit by bit. Don't do over sabi. If somebody look at this question now, you now say, okay, we are asked to get the effort of it, while we are asked to get the load. Remember, they say if a force of 500 Newton is applied to lift that particular load up. You understand? Yes. So we are looking for load this time around. Sorry, we are looking for this load this time around. Now I have it to be, my efficiency is what? 0.6, which is, let me use my blue marker. So my efficiency is 0.6 is now equal to, my load is unknown, divided by the effort, which is 500 multiplied by 1/5, because my velocity ratio is 1/5. Yes, let me just keep my phone. My velocity ratio is what? 1/5. So what do I need to do next? 0.6 is equal to load over effort. Now the next thing is I'll cross multiply this. But before I cross multiply this, pay maximum attention to this, because this is very, very, because some people will just come there and they'll now solve rubbish, and at the end of the day they'll just get nonsense answer. This because calculation is very, very tricky, and you knowing the formula doesn't mean that you get the answer correctly. Now 0.6, this is what I'm going to do for you to get your answer fast. I'm going to be doing 0.6 is now equal to, you multiply this. Before you be able to do cross multiplication, I have what? L over 500 multiplied by 5 will give me 2500. Then you will now cross multiply, which is L is now equal to 0.6 multiplied by 2500. Let me get my phone and calculate. Then 2500 multiplied by what? By 0.6. So I have it to be what? 1500. I have it to be 1500 Newton. So now let's look into the question to know the correct answer to this particular question. Alright, so now the correct option is what? Option D. You can see how I solve it neatly. Yes, you can see how I solved everything neatly. So I want you to solve the remaining 5 questions for me. Yes, I want you to solve the remaining 5 questions for me and give the answer inside the comment box. So I hope you understood what we did for today under calculations in a simple machine. Everything, both the terminologies, the question, both the bullet points. Do you understand? So you make sure that if you enjoyed the video, I want you to hit the subscribe button and make sure you submit your assignment. And also for those of us that is new to this YouTube channel, Notebook Team is an online tutorial that focuses on science students only. We provide intensive and quality lectures. Yes, we provide quality lectures. You can see how everything is being detailed. So if you want to know more about us, check the video description of this video on our YouTube channel, so you can be able to contact us, or use the link below to join our WhatsApp channel where we drop updates back to back. So let me see you in the next episode. Bye.